In this video, we're going to do a couple of extra examples with looking at properties of functions. So just to remind yourself, the first property we're going to talk about is a symmetry property, whether a function is even or odd. So an even function it's symmetric about the y-axis, and it satisfies the property that if you plug in negative x, so replace x with negative x, then you get the same function back. So f of negative x is equal to f of x. For an odd function, you have symmetry around the origin, and here you replace x with negative x, so you're still looking at f of negative x, but you get negative f of x. Okay, and that's how you can tell if the function is odd, so it has origin symmetry. So let's just do an example of that. So let's check g of x here to see if it's even or odd or neither. So what I'm going to do is look at g of negative x. Okay, so I plug in negative x everywhere I see an x. So it's 9 times negative x over negative x squared minus 1 plus 7 times negative x. Okay, now if I just simplify, so 9 times negative x is negative 9x. Negative x squared is just positive x squared. And then 7 times negative x is going to be negative 7x, so we can write this as minus 7x. Okay, now I want it to look like g of x. Right now it doesn't really, but I notice that both the terms have a negative here, so I can pull out that negative. Okay, and then I'm going to have 9x over x squared minus 1, and then plus 7x. Right, because this negative would have to go into both terms here, okay, so to give the negative both. And then we can see that this part here, this is g of x, exactly as it was. So that means that this is equal to negative g of x. So what that tells me, so since g of negative x is equal to negative g of x, I know that g of x is an odd function. Okay, so now we know that g of x is odd. Okay, so we did all the examples. So now the next example has to do with average rate of change. So remember the average rate of change over an interval, so we're always talking about it over an interval, so from x equals a to x equals b is like the slope between the two endpoints. So you take the change in the y values, which we often call delta y, and divide by the change in the x values, delta x. So that's going to be f of b, so the bigger x value, minus f of a, the smaller x value, so that's the difference in the y values, divided by the difference in the x values. Okay, so let's just do an example. So if I wanted to find the average rate of change between x equals negative 2 and 1 when I have this function, okay, so what we're looking for is the average rate of change on the interval from negative 2 to 1. So that's going to be f of 1 minus f of negative 2 over 1 minus negative 2. Okay, so to compute f of 1, I'm going to plug in 1 everywhere into the formula. So that's 1 minus 1 squared minus 1 cubed. And then I want to subtract f of negative 2, so that's where I plug in negative 2 everywhere. So 1 minus negative 2 squared minus negative 2 cubed. And all of that is over 1, negative becomes a plus, so 1 plus 2. Okay, so then if we compute, so maybe let's just to be clear, so f of 1 is that, f of negative 2 is that part. So you're plugging into the formula. Okay, now if I simplify, so the first box, the first f of 1 is 1 minus 1, so that's 0, minus 1 more. So that's going to be a negative 1. And f of negative 2, I have 1 minus 4, so that's negative 3. but then it's minus negative 8, so it's plus 8. So that's going to be positive 5. Oops. I did the wrong bracket there. So that's going to be that. And this is over 3. So maybe let's just write that down here. Okay, so here this is 1 minus 4 minus negative 8. Okay, so you end up with 5. So that's going to give me negative 1 minus 5 is negative 6 over 3, which is going to be negative 2. Okay, so that's my average rate of change over that interval. Okay, so that's how we find the average rate of change. The last example we're going to do has to do with secant lines. Okay, so a secant line is a line that connects 2 points on the graph. Okay, so you pick any 2 points on your graph, and if you do the line that connects them, so it's probably going to look different than the function, that's going to be the secant line. So something that we often want to talk about is the slope of the secant line. Okay, so to find the slope of that line, it's just the rise over the run, just like with normal slopes for lines. Okay, it's just a line. So we have 2 points on our line. Those are the 2 points that we picked for the line to go through. And because for those points they're on the line, but they're also on the function, we can use the equation of the function to find the y values. So notice at x equals a, the y value is f of a, where we're using the function f to compute that. So we have the same function as we just had before, and we want the slope of the secant line that connects these 2 points. Okay, so I'm going to call that m sec. Okay, on the interval from negative 2 to 1. Okay, so it's going to be the difference in the y values. So f of 1 minus f of negative 2 over 1 minus negative 2. Now, this might look familiar because we just did it. It's the same f, and these are the same points. This is the same as, oops, I wrote as twice. This is the same as the average rate of change in example, I think it's example 2. Let me just check that. Yeah, so in the one we just did, so the f function is the same, and we're looking for the exact same thing. Okay, so the average rate of change is actually equal to the slope of the secant line on the same interval. Okay, so we know that this is equal to negative 2. Okay, it's the same as before. So we don't have to go through all the work. It's going to be the exact same.